Imagine a machine that can soar through the skies like a hawk and then dive beneath the waves like a dolphin. A device that doesn't stop at the edge of the ocean. It just transitions seamlessly, diving into an entirely new world. No boundaries, no limitations, just pure hybrid freedom. Sounds like something out of a sci-fi movie, doesn't it? But this isn't fiction anymore. It's real, and it's here. Welcome to the age of the hybrid drone. A marvel of engineering that navigates both air and water with ease. Developed in secret labs and military test beds, these robotic shapeshifters could change everything from disaster response and environmental monitoring to underwater archaeology and futuristic warfare. But before we dive deep, both literally and figuratively, into this groundbreaking technology, ask yourself this. What happens when humans build a robot that can conquer two completely different dimensions of motion? Are we merely pushing boundaries or erasing them entirely? The story starts, strangely enough, with nature. Animals like ducks, penguins, and even flying fish have evolved the ability to move across both air and water. But it's no easy feat. Physics plays a cruel game at the interface between fluid and gas. Wings that excel in air struggle underwater. Propellers that thrive in the ocean churn inefficiently in the sky. Engineers for decades were stuck trying to reconcile the two. Then came a breakthrough. A team of researchers led by the Chinese Academy of Sciences unveiled a prototype drone capable of flying through the sky and seamlessly diving into the water with full propulsion, control, and recovery. This robot could hover like a quadcopter and then transition downward, penetrating the water like a bird hunting for prey. The mechanics? Genius. 4 rotors, carbon fiber arms, a waterproof shell. But the magic lies in its adaptive propulsion system. Each motor can sense the medium it's in, air or water, and instantly adjust the thrust-to-weight ratio, switching between lift for flight and torque for underwater navigation. Even crazier, this drone can stay submerged for up to 40 minutes. It's not just dipping in, it's exploring. But wait, it gets weirder. Enter the Navigator, a project out of Rutgers University in the United States. This prototype isn't just a drone. It's a shape-shifting robot that hovers above the ocean, then pierces the surface, dives 30 meters, surveys shipwrecks or underwater mines, and resurfaces, all autonomously. You might be wondering, why now? Why build flying submarine robots at all? The answer lies in versatility. Natural disasters, for example, often involve collapsed bridges, flooded zones, and damaged coastlines. Rescue crews can't just send boats or planes. They need something that can do both. Hybrid drones can scan the devastation from above, then plunge into murky waters to search for trapped survivors, infrastructure damage, or toxic leaks. Then there's military reconnaissance. Imagine a drone flying low over enemy waters, then disappearing into the ocean to scan submarines or install listening devices. No surface vessel, no detection, just stealthy, silent infiltration. It's not just war. Environmentalists are now testing these drones in coral reef monitoring. They fly to remote reefs, record bleaching patterns from above, then dive in for close-up footage, all in a single mission. One drone, 2 ecosystems. Sounds powerful, right? But also a little unsettling? Because as these machines evolve, so does their autonomy. The latest hybrid prototypes are now being equipped with AI-based pathfinding. That means the drone doesn't just switch between air and water, it decides when to switch. It maps terrain, identifies threats, and calculates the optimal point of transition. The boundary between mission planning and machine intelligence blurring rapidly. One drone in development can even recharge itself using solar panels while flying and kinetic energy while diving, giving it theoretical infinite range if left undisturbed. And this right here is where things get truly mind-bending. We're not just looking at a new drone. We're staring at the evolution of autonomous multi-medium robotics, a machine that learns, adapts, and survives in more than one domain. Imagine flocks of these hybrid drones surveying entire coastlines, diving into oil spills, scanning for illegal fishing, tracking climate damage, or enforcing borders. In fact, the Pentagon has already hinted at swarms of these drones in naval warfare scenarios, where air-water hybrid bots could coordinate underwater strikes, surface surveillance, and aerial decoys all in one mission. One scientist put it bluntly, this isn't about air or water anymore, it's about dominance across dimensions. But with that kind of power comes danger, because like all dual-use technology, hybrid drones can be used for good or for control. What if authoritarian regimes deploy these drones to spy on dissidents from the air and then from the water pipes beneath their homes? What if they become assassination machines that hide in oceans, waiting for targets to swim or sail? What happens when machines don't need runways or ships anymore? Just permission to move. And who decides that permission? The ethics of these machines are only beginning to be explored. We've already seen aerial drones used in controversial ways. But these new hybrids operate in blind spots, beneath radar, inside lakes, around coral islands where laws are murky. We're entering a world where no surface is safe from surveillance. Yet there's beauty here too. These drones could become explorers, discovering lost shipwrecks, monitoring endangered species, reaching deep-sea trenches that divers can't survive. One recent expedition used a hybrid drone to chart underwater volcanic vents, capturing footage that looked like scenes from alien planets. And the tech is only getting smaller. Micro-hybrid drones are in development, some no larger than your palm. Swarms of them might soon explore deep caves, underground aquifers, and tight coral crevices. A world once invisible to science, now exposed by robotic swarms. The future? Imagine this. You wake up in 2035. An earthquake has just rocked your coastal city. Emergency services are overwhelmed. But help comes, not from the sky or the sea, but from both. A squadron of hybrid drones arrives. They fly over collapsed buildings, dive into flooded subway tunnels, resurface with heat signatures of survivors. A single drone leads a robotic rescue. That's not just a technological leap. That's a new form of intelligence. A new way of interacting with our world. Because when machines can fly and swim, what else will they learn to do? The next generation of hybrid drones may move across all mediums: air, water, land, and even underground. Bio-inspired robotics might soon mimic octopuses, birds, and bats, adapting shapes and movement styles in real time. This isn't about drones anymore. It's about a future without physical limits. And here's the real twist. These machines are learning not just from humans, but from evolution itself. Engineers are studying how fish glide, how birds dive, how insects surface tension hop across puddles, and they're recreating it in machines. Nature took billions of years to master multimedia navigation. We just caught up. So the next time you stand at the edge of a lake or look up at the sky, remember, the divide between above and below isn't what it used to be. Somewhere, a robot might already be crossing it, and you might never even know. If this story opened your eyes to the mind-blowing possibilities and dangers of this new era of robotic evolution, then don't stay silent. Hit that like button, share it with your curious friends, and most importantly, subscribe for more journeys through science, technology, and the frontiers of human imagination. Because this is just the beginning, and I am TechBug.